Hello everyone, welcome to Engineering Workshops. For this video, we're going to solve problems in our Engineering Mechanics Statics textbook. So it's all about Chapter 1, Representation of Vectors using Rectangular Components. So I am going to solve problems 1.40-1.43. So just keep on watching guys and let's start. Alright, so for problem 1.40, again guys, you must have the copy of the textbook so that you will know the problem that I am going to solve and you will somehow relate to the given figure of our problem. So for problem 1.40, we need to find the rectangular representation of force P. So based on the figure of our textbook, you will notice that there is actually a right triangle from that figure. So before we proceed to our solving, first let me introduce the formula that we will be needed for us to solve this problem. So for the formula of the rectangular representation of force P, so this will be our formula. So F is equals to magnitude multiplied by its unit vector. So we already have our given magnitude, but still we need to find the value of our unit vector. So we need to find unit vector x, y, and z. Okay, so going back to our figure, we can actually solve for our unit vector z. So looking at this one, so this line is actually parallel to our z-axis. So therefore, we can use SOHCAHTOA, which is sine theta equals opposite side over hypotenuse for this one. So opposite side equals to hypotenuse times sine theta. And looking at this figure, this is our hypotenuse. And since this is our hypotenuse, we will consider this as 1. So 1 multiplied by sine theta. And sine theta is sine 50. So therefore, this will be sine 50. And if this is sine 50, this is cosine 50 since adjacent side is equal to hypotenuse multiplied by cosine theta. And now we already have the value for our unit vector z. We still need to find the value for our unit vector y and x. So again, looking at the given on our textbook, so this is where our y-axis is. And we need to find our unit vector y. So for us to solve for our unit vector y, we need to create a right triangle from this one. So how are we going to do that? We need to create a perpendicular here. And therefore, we can now solve for our unit vector y. So again, using this one, so cosine theta equals adjacent side over hypotenuse. So adjacent side is hypotenuse times cosine theta. But what is our hypotenuse? So our hypotenuse is cosine 50. So we will not consider it as 1 since it is not this one. So we will use cosine 50 multiplied by cosine theta, which is cosine 30. So therefore, it will be cosine 50 cosine 30. And now we already have our value of unit vector y. We still need to find our unit vector x. So how are we going to find our unit vector x? So again, going back to this figure, you will notice this one. And this is actually parallel to our x-axis. So therefore, here we can find our unit vector x. So by just using sine theta equals opposite side over hypotenuse, where opposite side is hypotenuse, which is cosine 50, times sine theta, which is sine 30. So therefore, this will be cosine 50 sine 30. And now we already have our values. We can now substitute this value to our formula. So this will be 30 quantity negative cosine 50 sine 30 plus cosine 50 cosine 30 plus sine 50. But why this is cosine 50 sine 30? Why it is negative? So this one is negative because this is actually on a negative side of our x-axis. So if this is positive x-axis, so therefore from here to here it is negative x-axis. So that is why this become negative cosine 50 sine 30. And this is positive since this is actually on a positive y-axis, and also this is positive since this is on a positive z-axis. So using our calculator, we can now solve for our rectangular representation of force P. So this will be our final answer, guys, for this one. So let's just check it using our calculator. So 30 negative cosine 50 sine 30. So that is why it is negative 9.642i. And another is cosine 30 cosine 50. So I will just change it to cosine. So of course this one is not negative. So it is 16.700 J. And for K, it is sine 50 times sine 50. So it is 22.981 K. Alright, so we're not yet done here. So if we want to check if the unit vector that we have been solved is correct, we have to check it using this formula. So we must square our unit vector x, y, and z, and it should be equal to 1. So let's try if it is equal to 1. So negative cosine 50. So actually we don't need to put negative since we're going to square it. So sine 30, because negative squared is also positive, so we don't need to put that negative anymore. So plus cosine 50 cosine 30 squared. So cosine 50 cosine 30 squared plus sine 50 squared. So again, guys, this must be equal to 1 so that our unit vector that we use is correct. So since this is equal to 1, so therefore, I think we can assure that our answer here is correct. So let's proceed to problem 1.41. So for problem 1.41, guys, it is similar to problem 1.40. So you must try to solve it on your own so that you can test yourself if you already know how to solve a rectangular representation. Okay? So for problem 1.41, we need to find the rectangular representation of R and unit vector directed from O towards A. So just like problem 1.40, the formula that we will be using is F is equals to magnitude multiplied by its unit vector. So from our given figure, we have a right triangle here. So we do have given magnitude, which is 240 mm, and we still need to find our unit vector. So for our unit vector z, so this one is our z-axis. So therefore, this will here we can find our unit vector z. So just like what we did on problem 1.40, so we're going to use SOHCAHTOA. So here, this is sine 40 since it was opposite, and this is cosine 40 since this is adjacent. And just like in the problem, this has a parallelogram here. So if this is cosine 40, this will be cosine 40. If this is sine 40, then this will be sine 40. So based from our figure also, this is our y-axis and this is our x-axis. So how are we going to solve for our unit vector y and unit vector z and unit vector x? So for our unit vector y, we can actually create a parallel line here, there, and after we have created a parallel line here, you can see that we have we create a right triangle from this one. So from here, we can now compute for our unit vector x and unit vector y. So we're just using SOHCAHTOA again. So as you can see, this is our hypotenuse, and this is our opposite side, and this is our adjacent side. So for our opposite side, it is hypotenuse sine 40 times sine theta, which is sine 50. So therefore, this is sine 40 sine 50. And then here, so hypotenuse sine 40 cosine 50 since adjacent. So this will be sine 40 cosine 50. And now, we already completed our value for our unit vector. We can now start substitute those value. So here, we can now compute for our rectangular representation of R. So 240 times sine 40 cosine 50. So there it is 99.1612i, and for J 240 sine 40 sine 50. So it is 118.177, and 240 cosine 40. So it is 183.851. Okay. And for us to check if the unit vector that we use is correct, we can square those unit vector, and it should be equal to 1. So sine 40, so let's check if this is equal to 1. Sine 40 cosine 50 squared plus sine 40 plus quantity sine 40 sine 50 squared plus cosine 40 squared. And as you can see, it is equal to 1. And how about, so we already have our rectangular representation of R. So what is about a unit vector directed O toward A? So this one is from point O to A. So our unit vector is actually this unit vector. So we're just going to use this one and calculate it again. So sine 40 cosine 50 equals, so as you can see, this will be our final answer. So then sine 40 sine 50, so let's just change it to sine, there 0.492, and cosine 40, there. So our unit vector will be 0.413i plus 0.492j plus 0.766k. So now we already have solved problem 1.41. So we already have answer. And now let's proceed to problem 1.42. So here we need again to solve for angle Z and rectangular representation F. So for this kind of problem, guys, first we need to be familiar with this formula and this figure. So if you have this kind of given, so definitely this will be the formula that we will be needed. So for us to solve for angle Z, so recall this formula that I am using, that we are using earlier for us to check if our solved unit vector is correct. Now we can apply this to solve for our angle Z. So for our unit vector x, it is actually equal to cosine theta x. Our unit vector y equals to cosine theta y. Same here, our unit vector z, it is equal to cosine theta z. So looking at this figure, we have a given angle of x, which is 50 degree, and then angle y, which is 60 degree, and angle z that we need to find. So applying this one, this will become like this. So cosine theta x, so cosine 50 squared, plus cosine theta y, so cosine 60 squared, plus cosine theta z, So cosine theta z squared equals to 1. And now we can solve for the value of our angle. So this will be equal to shift cosine square root. So I'm just going to transpose this cosine 60 squared and then cosine 50 squared. Cosine 60 squared minus cosine 50 squared. So I hope you already know why it became square root. And there, we have answer, which is 54.52 degree. So this is what I've done in our calculator. Okay? And then we're not yet done. We need to find for our rectangular representation F. So we're just going to substitute our given. So 240 Newton times unit vector x, y, and z. And again, unit vector x, y, and z is actually equal to this one. So cosine 50i plus cosine 60i plus cosine 60j plus cosine 54.52k. And again, by just calculating again, can actually solve for our rectangular representation. Cosine 50. So it is 154.26 to 69i, and then cosine 60. So 120, and cosine 54. 139.288 k Newton. So we already have our answer on problem 1.42. So again guys, this formula is applicable if our given figure, if our angle is from here to here, our angle from here to here, and angle is from here to here. So it depends on this kind of figure. And last but not the least problem for this video, problem 1.43. So for problem 1.43, we need to find the distance between A and B and the rectangular of the unit vector directed from A toward B. So for this problem, I am going to introduce to you again another formulas. So this will be the formula that we will be needed for us to solve for our distance and for our unit vector. So this is our given coordinates for A and B. And now let's start to solve for distance between A and B. So this will happen. So as you can see, A to B, so it is A to B, therefore what we're going to do is B minus A. So 4 minus negative 3 is actually equal to 4 plus 3, which is 7. So just substituting it on the formula, it will be 7 squared. And then B minus A again, so 1 minus 0 is 1. So 1 squared, and 1, it is 1 squared is actually equal to 1. And then plus 7 minus 2 is 5 squared. So by just using our calculator to solve it, so it will be square root of 7 squared plus 1 plus 5 squared. So I'm not going to show you to square the 1 because it's considered as 1. So 8.66 meter. So there, we already have our answer for our the distance between A and B. Now we're not yet done because still we are looking for the unit vector from A toward B. So this will happen. So B minus A, 7i plus J, since it's 1, plus 5k over this V. So solving using our calculator, I already store the value of our D at A, so 8.66. So 7 over A is actually equal to 0.808 there, 0.0808, and then for J, it is 1 over A, so 0.115, and for K, it is 5 over D, which is 0.577 K. And now we already have our answer on problem 1.43.